it was when we were too cold, so we just let it.
All right, this is the last little bit of P.3.
And we moved it 5 minutes later.
This is his YouTube video, guys, so please be quiet.
Yeah, guys. Please pay attention to the following assignments.
An open box
Oh no.
is made by cutting squares from the corners of a piece of metal that is 20 inches by 60 inches.
Oh,
Period. The edge of each cut-out square is X inches. Period.
I don't.
Find the volume of the box in terms of X. Period.
Whoa.
Then find the volume of the box when X equals 1, comma, X equals 2, comma, X equals 3, period.
Whoa. So I have to write down that question.
Kate, what's on your hand?
It was Bandit.
So,
Kate got a little scraped up.
Kate got a little spicy.
so this is a type of question that will come up on tests, possibly quizzes,
Goodness gracious.
possibly future chapters. So I would write some version of this, and you can decide, like, as we go through and see more details, what it is you want to write. But it will not be a waste of your time to write down all of this in detail. You can also have access to my notes, so it's up to you what kind of notes you take. But yeah, this is an approach or a method, I guess, or a pattern that's going to come up in the future. So what is this box? So I'm going to draw a square.
Do you have a pencil sharpener, Mr. Shale?
I have a pencil sharpener.
Could I use it real quick?
It's probably over there. So your goal in using the pencil sharpener or the calculator charger is to bump my classroom clock, because it will die if you bump it, and I'll have to bring it back to life.
Don't touch it, Cormac.
What does all this text mean? So I've got a box.
Oh, rap.
I'm starting. So this is like maybe this is like you could imagine this like as a metal smithing project. Go ahead.
My bad.
No, you're fine.
It's okay, Cormac. We're not missing grades.
This is Mr. Walker's class. I would be yelled at
How
right now.
dare you, Cormac?
Oh, I can yell at you.
Well,
He
Mr.
got
Walker
yelled at
one time,
last
Cormac
year.
had sharpened his pencil, and Mr. Walker's like, oh, over there.
No,
And then right as
he's
Cormac
toasted
gets to
on
the pencil
screen, Dad.
sharpener, he talks from, not even joking, 5 minutes on the board, and he's making Cormac just stand there, and he's like, Cormac, why did you show up with your pencil? He's like, I was waiting for you to finish. He's like, Cormac. Which I was like, that's a normal
Cormac.
Because
thing
in
to
Val would
do.
bring bacon every day, and Cormac once brought a piece of toast, and it was like World War III.
Dude, I brought toast with caramel on it because I wanted a sweet treat one day.
All right, so let's pretend we're in metal shop. We're in metal smithing, and we have a project
It's just there.
to make we're going to make a box by cutting squares out of the corners of a piece of metal that is 20 inches by 60 inches. Oh, 16. I might have said 16. The AI might have heard me say 60. 20 by 16. So it's not a square. It's a rectangle.
Oh yeah.
On the corner is.
Oh, 20 by 16, not 60.
Yeah, sorry. 20 by 16.
It's okay.
So I'm going to, so where do those dimensions go? So I'm going to start labeling stuff and start figuring this out.
Well, the 20 is obviously the side.
Okay. Yeah, the longer side.
Yeah.
So I want this to be 20 inches,
Like, who wouldn't put that?
and that makes the width.
Not me.
So if this is the length.
I know the area.
So what else can I put on here? What else can I start labeling?
The other two sides are both 16.
Yeah. So it's a rectangle. So I'm not going to label this one, and I'm only gonna label one side. And then what's this about the cutout part? Sorry, what?
We change it to 16 inches.
Yeah, 16. What is the edge of each cutout square is x inches? What is the metalsmithing project asking you to do?
Cut things.
Cut things. What am I going to cut?
Square x inches.
You're going to cut a square with a side length of x
Yeah,
out of each corner.
out of each corner. So I can kind of do that now. So I'm going to put a cutout. This is where I'm going to use my metal shears or my tool or whatever I have to cut out this. And what's the side length of the box?
So that would be 16 minus 2
The box, just the box.
x.
X, and then just because I want to, I'm going to fill this in with dotted lines. Meant to be dotted lines. Where's my dotted line?
Oh, is this our little lesson for today?
This is our mini lesson for today because we were almost done with P.3.
Interesting.
And so what am I representing with these dotted lines?
The folds.
The new
The
box. that has
folds.
option, yeah.
The folds. So I'm going to cut this part out. So this is going to be like waste material. These little X's. So what is my what's the? I think you started to say what's the width of my box? What's the height of my box?
So the height is x. The
height is X. Interesting. Okay.
I'm thinking like.
So what's involved with the area
The area is going
in
to
general?
be
In general,
just length times width.
length times width times height.
That's volume.
So the volume of the square,
Yes.
exactly what I said.
You said the area. And it's the volume of the box.
So length is
It's
gonna
the
be
surface area of the square.
The volume of the box is length times width times height. We already have a height.
Just x.
Is X. Okay. Let's think about length and width.
Length would be 20 minus 2x.
Okay, wait.
Well, 18 times 14.
Does anybody disagree with that? Does everybody see that?
I see it. Mr. Shea.
So this will be the bottom of the box. This will be the side of the box. These are all sides. and it's X inches tall. That means out of the 20 inches that I started with, I took out this X and I took out this X. So that makes the length of the bottom of the box 20 minus 2X. Is that okay?
Yeah.
All good?
10 inches.
So Cormac, can I have the width of the box? Width of the bottom of the box? This is
16 minus 2x. 16 inches minus
16, yes.
I had the answers, Mr. Shea.
16 minus 2X.
You never need to tap on me.
So, so length is 20 minus 2X. Width is 16 minus 2X. So one of the things it asked me to do is find the volume of the box in terms of X. So in a general sort of sense, like as a concept, we found the volume of the box in terms of length, width, and height. But we can express length, width, and height each in terms of X. So this becomes a function just of the variable X. This is technically this is technically a function of length, width, and height. Now I can write my length, width, and height just in terms of X. That's the first thing it asks me to do. So, Cade, how do I do that?
Right. Just in terms of X.
Yeah.
X times.
So I'm going to always start with my formula, and then I'm going to substitute in for the formula. So I'm going to start with my formula. What's my formula?
Length times width times height.
length times width times height, and now I can substitute in for each of those.
20 minus x.
2x. 20 minus 2x.
16 minus 2x.
16 minus 2x.
And just x.
And x. What, Cormac, close your laptop.
I got you.
What is the degree of the polynomial that I'm about to construct? Or that I am in the process of constructing? What's the degree?
It's a trinomial.
And you said,
Another degree. 2.
Mr. Shadle.
what does degree mean?
1.
Oh, yeah.
0.
I don't know
Degree's
if
the
the
highest
degree is like what
exponent,
it's
right?
put to, but I have a question. So, can you put this into like, where it goes like, parentheses, 20x minus 2 parentheses times 16 minus 2 parentheses times x?
What I wrote here?
Yeah, can
What do-
that become a function?
So v is a function of x.
So like, can you multiply those together so as you have like,
Yes.
okay, so
I'm asking you to, before we go through multiplying these together, after I multiply them together, what degree am I expecting to come out?
4.
2.
Why 4?
2.
Why 2?
Because you're multiplying the x's together. No, I don't know, man.
Why 4, Patrick?
Because when you multiply together, you get, when you multiply the the minus 2x in one by the minus 2x in the other, you get positive 4x squared,
Mm-hmm.
which when you then multiply it by another x gives you x cubed.
Yes.
So that, actually no, that's not quite how I did it. But it gives, that will be the one with the highest exponent
Which is what?
for the way I did it.
So the way you just described me is I'm going to multiply this thing that contains an x term times this thing that contains an x term times this thing that contains an x term. Anna, what am I expecting
Like the whole thing or just the
overall? This whole side is going to be a polynomial of what degree?
4?
Why 4?
Because wait now. Yeah. Because you multiply the 2 2's together. So then you have 4 positive 4x squared.
I did it.
And then with the other x it would be 4x cubed. And then since that's the highest exponent,
Yeah.
like in standard form the thingy.
Yeah.
Yeah.
Then the degree would be
4. No, 3.
yeah. Right, Patrick?
But the thing is, I feel like you would have to multiply the entire thing by
Yes.
x, and I did that first.
I did that last because like, no, it really messes up.
To me, it's easier to. So you can do it either way. You can distribute the x.
It doesn't change it though.
It doesn't change it, but to me, it's easier to foil the first one. So, well, I've heard some 4s, I've heard some 3s, I've heard some 2s. Let's multiply it out and see what we get. How do I do this step by step?
Okay, so first thing you want to do is 20 times 16.
What's 20 times 16?
320.
Why 320?
Because that's what my multiplication told me.
Because
In-
what? Wait. Because
Oh.
10 times 16 is 160. And then if you times that by 2, it's 320.
So if you have something that you can break down easily,
Well, 60 times 2.
you could say this equals 10 times 16, but then you also have to put in a 2, and that can give you 2 times
16 times 10 was
160, 320. What I was thinking was I can easily ignore the 10 and bring it back in later. So in my mind, I do this by just saying this is going to be, I'm going to reserve the 10 until later, and then I can easily multiply 2 times 16. What's 2 times 16?
32.
32. That gives you 320. So this is done easily in your head just by ignoring the 10 for now. 16 times 2 is 32. put the 10 back on 320.
Okay.
So
And then-
so 320.
After that, you do 20 times -2, which is -40x.
Negative 40x.
Then after that, you do the opposite. So you have 16 times -2x, which yeah.
That's negative 32.
Which is -32x. And then last thing you have is -2x times -2x, which is positive 4x squared. So I put that all together.
And I'm not done. I'm not done. I need to write an equal sign in between each step and carry all my stuff forward, even if I'm not using it right now. What do I need to carry forward?
The x.
The x on the outside. Okay, continue.
Next thing I did is I put it in whatever the form is called, where you're like the highest
Standard
exponent,
form.
standard form. So you have 4x squared minus, minus 4x. No. What? Oh, wait, sorry. 4x squared minus 72x plus 320.
And then?
And then I times that.
No. Each line needs an equal
And
sign.
then it equals, yeah. And then
So-
you times that whole thing by x.
So I see a lot of people not doing this. This is the practice you should do. You should start with what you're looking for. You should write out the variable in terms of what, the function in terms of what variable. You should start with your pattern or your formula. You should substitute, and then each line gets an equal sign. So you're not just working on this part by itself. So each line goes forward. So we're not quite done with this one. It's missing
Equals.
I know an x.
an x. Okay, and then
And then you have everything times by x. So you have 4x to the third minus 72x squared plus 320x.
yes,
And that's how it's done.
that is the answer. That is how it's done. So this is the answer to express the volume in terms of x only. You will see this kind of reasoning again. I gave a similar question on the final last year. You will see this again.
Now we put in our x's. Who's ready for this?
Okay, and what does it want for x's?
1, 2, and 3.
Okay, so we want to know x of 1, x of 2, and x of 3. Let's do x of 1 the algebraic way, and then I want to show you a graphing utility way to do it easily.
I do x of 1.
Well, you just did the whole thing.
But I'm on a roll.
You're taking all the bonus points.
But I don't.
All right, somebody do x of 1, not Barrett. You're banned.
I'm banned.
I'll do it. So you would plug in x of 1 just into the x's.
So what do I write here on the left side?
V and then
V of
1.
Good job.
Okay. So then it'd just be the same thing because it's all 1, right?
Hmm?
You're substituting x for 1, right?
Yeah, 1 in for x.
Yeah, so it'd all be this. It would just be. Wait. So it'd be 4 cubed.
It's not 4 cubed.
41 cubed.
It's not 41 cubed.
4 times 1 cubed.
Yeah, this means times.
The ones to the one
Oh,
has
so 4
What
times-
does this third power apply to?
The
the
x.
x.
The x only. If I wanted to apply to both, what would I need, Matt?
You would need parentheses.
I would need parentheses. That would be a different answer. I am only cubing the x, and these things are multiplied together. So it's 4 times
1 cubed.
1 cubed.
And then, which is just 4.
Yep.
And then it would be minus 72 times 1 squared, which would just be 72.
Okay.
And then plus 320 times 1, which is just 320.
Right. If you need to keep yourself from making a mistake by going through this step, you may. If you feel comfortable just writing down this step, because you're carefully thinking in terms of x being 1, you could just write this step directly.
So
And then
equal 252.
252, and then am I gonna leave my answer like this and lose half credit?
No.
No, you're
Well,
gonna
We
use
would
the
have 252 inches.
So a length is inches, an area is square inches, a volume,
Is inches cubed.
and so I'm just gonna write,
252.
I'm gonna write inches cubed.
Yay.
You could write cubic inches, for inches squared. You could write square inches. I don't mind about the notation as long as you're including the units. That's how to do it by hand. That's how to do it without a calculator, if you need to do it by hand. I'm going to show you. So this applies to your.
Can I do? Oh, never mind. I need my
Okay, for practice, yes.
Yeah. So for
Go-
the
go,
next
Cormac.
one, for 2.
So what do I write on the left side of the equation?
Oh, 20 minus 4 times 6.
On the left side.
Oh. X equals 2? An equal sign?
Oh, you know what? I don't know why I put parentheses here. This is supposed to be x equals 1, 2, and 3.
The X.
So I'm going to write an equal sign. What goes on the left side? Here we were looking for the volume when x equals 1.
Volume X equals 2.
What do I write?
V parentheses 2.
So this is function v at value 2, or v of 2. V of 2 is what?
20 minus 4 times 16 minus 4.
20 minus 4. Where are you? So I'm filling in this equation when x equals 2.
I think you're filling in like one of the previous ones.
Yeah, I was just
The
filling
answer.
it in like
Hold on.
normally to find the volume. My bad. Why do that method as opposed to just
So you were doing 20 minus 2 times 2, 16 minus 2 times 2
yeah?
times 2. So this
Why not
this
do-
volume, these are all correct. That's why I have an equal sign. These are all good. You could fill in any one of these. You're not wrong. So this is why this method is better. First of all, write down your formula first. It makes it easier to fill in. And then all of these steps is a complete equation. This is completely represented. So even though we might have preferred to work on the FOIL separately, we didn't. We worked on it in the context of carrying forward all the information, if that makes sense. Do you understand what I'm saying?
Not really, no.
So when I started with this line,
Yeah.
I'm gonna take this line out here. I'm gonna bring this out. So I might have been tempted to just do the FOIL part
Yeah.
and not bring the x forward and not say equals in between each line, because then I can FOIL this out first, outside, inside, last,
Yeah.
and get an answer. But then it's not an equation for the volume.
Multiply it
This
by
is just
5.
2 factors of the volume,
Okay.
and then I have to multiply it by the third factor.
Yeah.
It's easier to do, it's more straightforward to make sure that each line has an equal sign and each line then does stand on its own. And you can absolutely solve for v of 2 by plugging into this, because these are
that's
all
what I did.
expressions of
Yeah.
the volume in terms of x.
Okay. So how is it not easier to just do the top method as opposed to like having to do what feels like way more arithmetic at the bottom line?
I'm not mad either way. I'm
Okay.
fine either way.
So then just do 16 times 12 and then.
So it's
equal.
harder to, so for you, it seems like less work to jump to the answer, but when you're writing out your steps, it's better to fully communicate what you're doing.
Yeah. Okay.
So here we use this one, and I didn't feel the need to write it again. If I'm gonna do something else, I think I might need to write this again. So v of x equals 20 minus 2x, 16 minus 2x times x,
And then
and then fill it in.
you do
20 minus
4
20 minus 4,
times 16 minus 4
16 minus 4
times 2.
times 2, and that gives,
16 times 12 in parentheses times 2.
right,
And then 16 times 12 is 192. And then times 2 is 384.
am I done?
384 is the correct answer.
384 inches cubed.
So if this is my answer, I get half credit.
I said cubic inches.
Okay, in cubic inches, that's my complete answer. Do you want to do 3, or do you want to see the way to have technology do a lot of work for you?
We should do
Let's-
technology.
Let's do technology. Let's go. Okay. So what if I said,
Oh,
so if I say find, Baron, what are you doing?
come on, man.
What?
Lock in, Baron.
Walk in there.
Are you taking notes?
Yeah.
So if I said find the first 20 values, like if I say find V1, find the volume when x equals 1, 2, and 3, you could just do it that way, and no big deal. It's not a lot to do.
However,
In Desmos, if you wanted to say find the first 50, find the volume for x equals 1 through 50 in integers, I really wouldn't want to do those hand calculations. Would you?
No.
No. So here I could do f of x x equals, what's my formula?
Yes.
What's my final version of my formula?
4x cubed minus 72
Four-
x
oops.
squared.
4x cubed. I'm still in the exponent right now, so I'm going to press the right arrow to drop down. Plus,
Minus
minus
72
72 x, there's a button for squared, and then plus
320x.
320x. Interesting, look at that thing.
Whoa. It goes in so many different places at all the same time.
I'm not gonna eat that. Like, that looks so wrong.
Oh my god. Yeah.
So if I press the little plus button in the corner, I can get a table. So press table. By the way, if you're going to do a screenshot, you should click on note, and you should say, this is homework from P.3 number 11. And then move that up to the top. That way when you take your screenshot, I know what the screenshot is for. Please always use this is a comment. Oh, sorry, this is a note. So you do plus note, and then that lets you just type whatever text you want. So that lets me know what problem this is. This table gives me a column for x1 and y1. I'm not going to use that. I'm just going to use plain x, because that's what I have for my function. And then instead of y or y1, what am I going to put here? Huh?
Plain Y.
No, not plain y. I didn't use plain y. Up here I could have used plain y. I chose not to.
V.
The number you want, 1 or 2, right?
I didn't use v either. I like that guess, but I didn't use v. I didn't use z. What did I use?
The number you want, like 1 or 2.
What's my function name?
V.
What's my function name here?
1.
F.
F. So I'm going to change this to f of x. F of x is synonymous with y. So here I'm going to put, let's say put 0. All right, this is the awesome thing about Desmos. I'm going to put 0 here, and it's going to give me 0. Like if I put in 0, what would we expect?
0.
Right, because every term has an x, right? So if x is 0, the whole volume is 0. Now if I press enter and I put in 1, is that what we got? 252?
Indubitably.
And now watch what happens. I'm not going to put any more numbers in. I have 2 integers in a row. I'm just going to keep pressing enter. So now if I want the first 20 or the first 50, I can easily do that. Oh, look what happened. I started with x is 0, and I got a volume of 0, and then it went up, and then it came back down to 0.
And does this work with all the equations that we listed, or only this one?
So I'm going to.
Well, they're all the same equation, just.
They are all the same equation.
So it would all be the same.
So what if I put in a different version? So I'm going to say, I'm going to do this up here. Cormac, give me a different version of the same equation. I'm going to call it g of x instead.
Okay. Equals 20 minus.
Parentheses, right?
Yeah.
20 minus
2x
2x parentheses
times 16 minus 2x.
16 minus 2x
All of
times
them.
x.
times x. Before I type x, what are we expecting the red and the blue lines to do?
They're gonna match.
This should match up, right? So if I can click over here to display or hide either one, and they match up, right? And I can also verify that by adding another column here. What should I call this column?
G of x.
G of x. They match up? Is that what we were expecting?
Yes.
Yeah, we were expecting that because we carefully put an equal sign between each line, and we made sure that each line equals the line following it. So in whatever version you want your v of x to be, you can graph it that way. At any point, I could have used a different function name and just reflected that function name here. I could have called it v of x. I could have called it y. So you've got some flexibility there. But if you need a bunch of values, or if you need to see the overall behavior of the curve, then a table in Desmos is the way to go. While we're doing that, by the way, have I told you about Desmos test mode?
No.
So on tests or quizzes that have the use of a calculator, you can either bring your TI-84 graphing calculator, and I'll put it in test mode, or you can on your iPhone, iPad, Android device, Google Chromebook if you have one. There's an app that's very much like Desmos, but it's Desmos test mode. So it's this blue app icon called test mode. So when I go into that, it's going to lock me out of the other uses of my phone or my iPad or my whatever the device is. If I click start practice, that's just like being in Desmos.
How do I get back into my phone?
So I'll show you. So to make sure that you're completely locked out for the entire test, you're gonna click start test. Like I'm going to write down the time that we start the test. So we're gonna start the test at 1:35 p.m. Let's say. I'm gonna write that down. You're gonna click start test mode, and test mode wants to start assessment mode. You will be unable to use other apps on iPad until test mode ends assessment mode. Do you want to allow this? You click yes. Comes up with a little banner that says your iPad is now in test mode. I can tell you're in test mode because now it has a green banner with that next to the word Desmos. It's got that badge, and I know that you're in test mode. Barron, sit up. Don't play Roblox until 3 a.m.
I went to bed at a reasonable time last night.
What time, Aaron?
So
10:30.
So while I'm in test mode, I can use all the functions. I can add a table. I can add expression. Here's some statistics stuff. When I'm typing here, I've got access to these functions. So very similar to regular Desmos, but like if I try to scroll up or swipe up to get to another app, I can't do it. So it's locked out. So meanwhile, the app has noticed what time you started test mode and how long you've been in it. So I can build my function. Maybe I want to call it v of x, all this stuff. And maybe I want to make a table and put my x here and put my v of x here. And I can add my values, just press enter, and it'll propagate any integer values. If I have non-integer values, it doesn't know what to do, so it won't do that. But so I can use this the whole time I'm taking the test. I can delete it, I can add new stuff, whatever I need. By the way, I didn't show you this function earlier. If I just want, like, how would I get Desmos to tell me the value of the function at 1.5? Because it's not on my table. Matt, how would I get Desmos to tell me the value of my v function at 1.9?
You would put in v equals 1.9, right?
Not v equals in 1.9. How did we do it when we were figuring out stuff? V parentheses 1.9. This means v at 1.9, and then it gives you that value. So 1.9. Were we expecting it to be something between 3 and 6?
Yeah, that makes sense.
And it is 3, and it's 1.9 is pretty close to 2, and my 5.7 is pretty close to 6. Right? So you can get it to, like, you put in your function here. If you need it to evaluate it at some number, that's how you can do that in test mode. Now, I've been taking my test for 65 minutes, and I'm ready to get out of test mode. You cannot do this at your desk. So you bring your device up to me, you hand me your test, and I say, okay, go ahead and stop. So you click done. If you do this by mistake, you just hit continue session, the clock still keeps running, no problem. So if you click done, you didn't mean it, hit continue session. If you're really done, you come up to me and then you click done, and then I see that you've been in the test for 3 minutes, and we started at 1:35, almost 1:35. And so I say, okay, you're good, and then you can click I'm done, which means it's gone away, and then you can use your other apps. If you don't have a full count on your timer, what does that mean for your test?
You're cooked.
If it is a 0, it is a 0.
Why would people need to use other apps? Isn't that most like
Because maybe I want to use my notes app, or maybe I want to look online, maybe I want to check with Google. So there is that little bit of a pitfall. You don't want to get a 0 on your test, but you can always, as long as you're caught up with your homework, you can always retest. So that's not a punitive 0 that has to stay there forever. It's you didn't show me that you were in test mode the whole time, and so you get a 0, but then you just schedule a retest. That sounds a little treacherous. That sounds like something that you might want to avoid. If you want to avoid that, you can use your TA84, but a lot of people love Desmos. So the math department is trying to give you an option to use Desmos on quizzes and tests if you want.
Could we possibly use both?
Yeah,
Because like some things are easier to do on a
yeah, for sure. Yeah, you can use both. So TA83, TA84, Desmos test mode. Your TA83 has to be wiped of memory. Your TA84 has to be in test mode, and the only app that you can use is Desmos test mode.
What about a TI-82, just because I randomly have one?
I don't think so. I would have to look at it. I would have to look it up. So TA83 is not. So what we're avoiding is the computer algebra system calculators that will solve stuff for you.
Yeah.
So CAS is not allowed. But TA83 is fine. TA84, any version of TA84, and there's a lot of versions.
Yeah.
They're all fine, and Desmos test mode is allowed. That's it for today, actually. So you should feel free to open the WebAssign. I'll make sure that you have access, and you can work on homework for the rest of class.
Can I use my phone?